Well, hello again. My name is Dr. Scott Boskovich, and again, I want to welcome you to the department discussion on electromechanical engineering and technology. As I mentioned before, and then I'll elaborate again, we're going to go into a little bit more depth on the topics that you saw in the other presentation provided by the College of Engineering. We have two programs in our particular department. One program is called ESET, or Electronic Systems Engineering Technology, and the second program, MSET, is the Electromechanical Systems Engineering Technology. So we provide both of these programs within our department. Our Electronic Systems Engineering Technology, or ESET, as the name implies, is electronics focused. Maybe software and computer programming also is included in that description. On the other hand, our electromechanical program is really more geared towards mechanical systems. And these systems really could be mechanics, so how things move, could be thermodynamics, so obviously temperature is involved with that. We have fluid dynamics, also a very key element in mechanical systems. And then of course, the question is, how do all of these things relate? For example, when we think about electromechanical engineering, we think about robotics, right? We think about how a robot might move. So for example, as you see in this chart, we have on the bottom, you can see that you have students who have built and designed and programmed their own autonomous vehicle. That's an electromechanical engineering system. And we look at the technology that goes into that. What we want to do is understand how we take that theory and how we apply it to an overall system at the same time. So we know that most mechanical systems out there don't live in their own little world. They actually have to have electronics that are associated with them, and there's quite often software that's associated with them. And so what we do is we take the theory of all of these topics and relate them so that they can be applied and actually designed in the real world today. So we look at the theoretical topics of all of these, and then how do you build one of these things? How do we take this fundamental theory and then build it? And we do it in a hands-on manner. So as you see, students are building autonomous vehicles. In fact, they compete against one another in one of the particular classes. On the other hand, we also think of a robot as maybe a robot arm. Again, we see that in one of the other pictures shown below. And in that class, students built their own robot arms from scratch. In both of these classes, they wrote the software that went with it. They designed the mechanical system that went with it. They designed the electronics that went with it. And the entire class worked together in individual groups. So you had groups of say 4 or 5, and they would work together like you might find in an industry type of setting. So we want to also not only explore the relationships between the design from the theory to the practical of an electromechanical system, but we also want to prepare you students as somebody who will be industry ready. That is somebody who, when you graduate, knows how to work in teams of multidisciplinary functions in order to implement the design. And so we do that through a variety of different topics of all the mechanical type systems and electronic and software based systems. We also look at a lot of theory, as you can see in the pictures in the upper right, that one of our professors, in fact, designs turbine machinery, turbine engines. And we take the theory of thermodynamics and fluid dynamics, and then how to bring these two together in such a way that we can create an engine. It's a very fascinating topic that Dr. Akbari is doing. Our faculty that we have has extensive theoretical knowledge, as you can see from these couple of pictures. We also have extensive industry experience. Some of us have 20 years of experience in industry as well as teaching. And then others have a lot of academic experience that they can bring to it and really help facilitate the execution of bringing this theory to a hands-on application, which is a key to engineering. Key to engineering is hands-on design, right? We can't build a theoretical system that can't be built. We focus on designing systems that can be built in the real world, because at the end of the day, we live in the real world. So we really try to understand some of those relationships. Now, you might be asking, some common questions that we get quite often is, I'm a high school student. What do I need to do to prepare myself to be successful in college, and particularly in your program? And that's a great question we always get. And the first thing you can always do is ask yourself, what do I need to do to get good grades? What do I have to do to really understand the material? We want you to be taking your math classes. We want you to be taking your science classes. If you can take your AP calculus, great. If not, work towards it. That's okay too. Continue to strive and do well in understanding the topics. You might want to take a physics class or an AP physics class to really help understand the material. So when you come into our program, you're really ready to hit the ground running. So those are some things you want to do. Now, if you haven't maybe done that yet, that's okay. You can still take them here at Cal Poly. And we encourage you guys to take courses at Cal Poly in the math and science department, obviously. That's something we want to have a good relationship. So we're not saying to not take those courses there. We want you to take those courses there. Another thing you can do, and this is kind of a little bit different, is we want you to be involved with programs and clubs, for example. The VEX robotics is always a great opportunity for students to learn robotics, the electromechanical theory that goes into it, the software that goes into it. So those things also help you learn how to work with one another as well as working on technical topics. That's very typical of what you might see in a Cal Poly program with electromechanical engineering. So those are some of the other aspects of it. We also want well-rounded students because at the end of the day, the industry wants well-rounded people. They want people who will get along with one another. Maybe you've been on a team before and you know how to talk to one another. That's key. Communication is a key component. So be a diverse student, also work on getting good grades. And there's nothing to say you can't do something on your own, to go out and pick up an Arduino project or some other kind of project and learn how to do it. Nothing should stop you from that. And we encourage students who want to do that. We see a lot of students who come into our program who might have done that type of thing because they're just very, very interested in the material. Another question that quite often comes up is, I'm involved with my high school students Project Lead the Way. How does this help me? For example, you might have been told, this is really good for you to go into engineering in college. And I actually agree. I've been involved with working with high school students who are involved with the Project Lead the Way program, and I think it's a fantastic program. Some of the things that you learn there is project-based designs, so how to work with one another, how to work on what a requirement is. You learn about requirements. That's very good. You learn how to construct and build something. You learn how to test it. You learn how to implement it. And sometimes you learn from your failures. That oftentimes happens too. So that's something we also like to see. What can it also do for you? Well, we teach an Engineering 1000 class. It's a freshman level engineering curriculum course. And one of the things, if you go through your Project Lead the Way, quite often you can have that replaced and you don't have to take that course. So you've already worked on this for 4 years and you're able to maybe mitigate the units you would otherwise need to take for that particular class. Excuse me. Also, depending on the courses you take, such as your digital class, you might be able to take that. We could use that as part of a class towards your curriculum. So there are some classes that we also provide you the opportunities to get credit for in college, which is really good, right? It's like taking your AP test. And we want to encourage you guys to go into those areas. And so if you're involved with that, or maybe you're a freshman, you say, hey, I really want to go into engineering. Maybe I should take this Project Lead the Way curriculum. Yes, do it. It's a fascinating program, and I do encourage it. Now, some of you may be out of high school. And in fact, sometimes a question says, I'm a transfer student. How do the classes transfer to your program? We work quite a bit with a lot of the community colleges, especially in the local Southern California region and others, through this program called assist.org. And assist.org is a way to allow students to see what they can take at a community college and how that can be applied to your Cal Poly curriculum. In general, you might want to take your math classes and your physics classes and a lot of your other GE classes there as well. But what we also encourage you to do is, if at all possible, to take your engineering curriculum courses from Cal Poly, because we've tailored them in such a way that it fits the program quite nicely. Now, that's not to say that you can't take courses at other community colleges that will be transferable. Many of them do, but I would encourage you to look at the assist.org further to see how they transfer. If you ever have a question about a transfer course, you can always contact Dr. Masavi, which I'll provide that link to you in an upcoming slide, so that you can reach out and ask those questions, because we want to always have a good relationship with any incoming students so they're prepared to come into the program from day one. That's one of the big things we want you to do, is always to be prepared for the curriculum. Now, somebody asks, and quite often, can you elaborate more on what electromechanical engineering means? And what it really comes down to is understanding more than just this term mechatronics, which oftentimes gets thrown around. You saw examples of robots, maybe autonomous vehicles, self-driving cars. Those are electromechanical systems. But even inside of those cars, for example, the transmission, that's an electromechanical system. There's some control software that's inside an embedded processor, which is driving the electromechanical, the mechanical system, and all those things have to work together. An engine is another clear example. So we have faculty members who are working on engine design. They're doing research, active research in engine design. So you have to worry about how does the engine perform its combustion? And then what are the parameters for that combustion to ensure it's working in an optimal manner? So again, we have software working with electronic sensing, working with actuation, which then drives a mechanical system. In this case, the system is both thermal and fluid dynamic and mechanical related too. So we can see in an engine a very, very clear example of that. One of the other applications, besides robots, engines, we could also see, we're looking at the application of just a pure electromechanical system where we're dealing with a mechanical system which has a lot of sensors with it. So which again, see that as an electromechanical system. So we really deal with how does the software that we need to write need to work? How does the electronics that we need to sense that software need to work? How does it allow us to sense the mechanical system that it's controlling? Again, could be fluids, could be thermal, could be mechanics. And so we look at from the electronic side of things, we look at what kind of transistor systems we might use, what kind of processing we might use, how does the processing work, what kind of software do we use? Obviously, we do teach a programming language for C, but we also look at other languages. In fact, we also look at how to design your these custom chips called FPGAs, field programmable gate arrays, which we design modern digital logic designs inside of, and we can even create custom processors for that as well. So we want to optimize how the electrical interfaces work with the mechanical interfaces, for example. So we look at the sensors. The sensors are nothing more than a set of electronic devices, and we look at those quite closely too. And we also go into all of the circuit theory that you would expect to see the electronic systems courses require. So we look at electronic systems, we look at the electronics of the electronic systems, we look at the software for these things, how they relate to one another, and then of course how they interface with a mechanical system. Now, another great question, and I love hearing this question, is when students, they want to come to the program and they say, I want to go to graduate school, and I also maybe want to pursue a master's degree and or a PhD. And I think that's really, really great. One of the things we focus on is to have you industry ready, so that when you graduate from here, you're able to go and get a job. That's one of the reasons why you come to the college and why you come to university. Cal Poly is one of the best undergraduate engineering universities in the country, and we pride ourselves on that. We know you want to be industry ready, but we also want you to be ready for additional work if you so choose desire. We've had many, many students go on to get a master's degree from our program, and depending on the program you go into, you might have to take some additional courses by that university. So that's one of the things you want to look into from the university you might want to go to. In fact, we have many students who actually go on and get a PhD in some related engineering, such as maybe electrical or mechanical. And moreover, we're actually started a new program that we're hoping to pilot very soon called Electromechanical Engineering. It's a master's degree in electromechanical engineering, where we focus on the controls theory of an electromechanical system, of a system that supports the robotics, sensor fusion, nonlinear and linear controls theory, how to control an engine, like we just mentioned before, how you might have a non-linear or a system that's deformable, maybe you have a mechanical system which is very deformable, and it's intentionally deformable. So we look into those types of things in our own program that we're putting together now. So I hope these questions are questions that you might have had. If you have additional questions that maybe I haven't elaborated on yet, by all means, send us an email. We'll be happy to get back to you. One of the questions you might be still asking that I haven't addressed yet is, well, I have this electromechanical engineering degree. What do I do with it? And so what we look at here is, what are electromechanical engineering technology graduates? What do they do? And so what we do is we like to make, obviously, a difference in people's daily lives, right? So we go through and we design systems that apply the theory of what we talked about in our coursework. Okay, so you could see yourself working for a robotics company. There's several students of ours right now who are working for a robotics company for factory automation or or I should say warehouse automation. We do both actually. So we do factory automation and warehouse automation. Warehouse automation is a very fascinating field right now. It's kind of like the Amazon world where warehouses are being managed by robots. And so those robots, several of my students right now are designing some of those very aspects. We go into factory automation. For example, maybe you're working for a beverage company and the beverage is being controlled through a set of automated machines. They'll design and they'll put together those systems that can help provide that kind of automation. One of my students happened to be working now for Frito-Lay, and she is in charge of an entire group of engineers who figure out how to make the chips and the things that you're going to eat from Frito-Lay. So we have robotics, we have automation equipment, we have sometimes students will go into the test and design, or the test and they'll take a system and they'll want to test it. We want to make sure it works. Many of our students work at JPL and they're in the test and verification teams. So before we launch systems to go into space, we need to make sure they're going to work. We can't fix them once they're off on Mars. And so it's a very rigorous process to do this type of testing. Many of our students can go off and work in those departments as well to make sure it's going to work. And several of them also will work in the mechanical design of the arms and the actuators because they really understand the electromechanical interface between those types of systems. Many of our students work at Northrop, JPL. We have Edison, where there's a lot of students working there as well, Boeing, Extron, Murray Microwave, Lawrence Livermore National Labs, Western Digital, and Raytheon. So a lot of the Southern California companies really like our students when they graduate from our programs. So if you have any further questions that I haven't maybe had a chance to highlight, then by all means, please send us an email. The best way to do that is to send it to Dr. Masood Masawi. He is the chair for the department. You can reach him through the department's email, which is EMET, Electromechanical Engineering Technology, at cpp.edu. And you can always ask us a question by calling us. You have our phone number right there. And I encourage you guys to reach out to us and ask us more questions. With that, I hope you had a good day, and I look forward to those questions. Thank you.